Hi, I'm Tom Pinnell, and I'm here to talk to you about the three stages of the origin of the solar system. I'm going to give you a brief history. We're going to talk about the protoplanet nebular model, the planetesimal theory, and we're going to do a conclusion. Quick history, the theory started in the 18th century with Immanuel Kant and Pierre-Simon Laplace. Immanuel Kant lived from 1724 to 1804. He lived in Königsberg, Prussia, which is modern-day Germany. He was a philosopher, but he published the Universal Natural History and Theory of the Heavens in 1755 that laid out his theory of the solar system. Pierre-Simon Laplace lived from 1749 to 1827 in Paris, France. He was a mathematician, astronomer, and a statistician that dealt with probabilities. They both came up with the protoplanet nebular model, which describes how the solar system was formed. It goes in three stages, and there's three key words, I guess, that we need to know. One is a nebula, which is a big cloud of moisture, gas, and dust. Protoplanet, which means it's the beginnings of a planet, and a protostar, which is the beginnings of a star or our sun. Okay, in stage A, it happened over millions, possibly billions of years. When stars explode, they become supernovas, and the elements from those stars go out across the universe. Those elements get collected in one collective area, and it starts to make the nebula. The elements get trapped into gravity. They start a slow spin. And the nebula is like light years across. Okay, and then it goes into stage B. Stage B is the nebula starts spinning faster due to the gravity of the whole thing. And the center, because everything's spinning and contracting, falling into itself, the center starts to get hotter and hotter. Kind of like if you can see this picture, kind of like if an ice skater is doing a spin, if she has her arms out, she's spinning kind of slow. The minute she puts her arms in, she starts spinning faster. Same kind of concept. So along with stage B, again, it keeps spinning and contracting more and more, and becomes this accretion disk that you can see here with the hottest area in the center of it. So that becomes the proto-sun at this point, and it builds more and more gravity, and it compresses the outer elements, and those elements compress together to become the protoplanets. All those elements start collecting together more and more. Okay. Then it goes into stage C. In stage C, the sun gets so hot that sometimes it has flare-ups, and those flare-ups knock the hydrogen and the helium off of the inner planets, or off of those inner rocks that started forming and spinning. So that's why our planets up to Mars don't have heavy atmospheres. But the outer planets are so far away from the sun at this point from the flare-ups that they keep their thick atmospheres that they have. Okay. Now, the new theory with how the planets are formed is the planetesimal theory. And scientists are learning this from comets and asteroids coming down to the Earth or making their way to the surface of the Earth. They're finding out that these different rocks have have remnants of their own magnetic fields. And those magnetic fields or the remnants of those magnetic fields in the rocks are giving scientists more to think about, and they're finding out that the planets may have been formed by these rocks colliding instead of by spinning and collecting dust over a long period of time. So by all these planets colliding, they actually form faster. Planets could have actually been formed within 1 to 3 million years. Okay, so today I've talked to you about a brief history of the planetary nebular model. Talked to you about Kant and Laplace, how they came up with it in the 18th century. Talked to you about the three stages of development of the model, and I talked to you about newer models and newer science that they're finding out. Thank you very much.